All right, I'm back. Here's part 2, number 19. Can you find the zeros? So first I look at it, see if I can factor this. I can look by grouping. It's not going to be factorable by grouping the first two and last two. So I need to create a list, and then I need to think which number on a list. Now I'm going to save you time. I'm going to tell you that list is long, and there's one number that works in this super long list. I'm going to save you time. You think, hey, how about on the exam? On the exam, I'm not going to give you one that's this ugly, that has such a long list. But the number on your list that works is -3. That's it. You have a long list, 1, 3, 9, and so on. It's -3 that works. Let's see if I can do this. And there we go. So -3 is a rational zero. Then what's left over is x squared minus 8x minus 27. Again, if you try to factor this, there are no two numbers that multiply to -27 add to -8. The diamond doesn't work. So now what? So we're going to complete the square. So I'm going to add 27 to the right side, and then we have a formula to complete the square where we take the b value, divide by 2 and square. So it's -8 divided by 2 and square it. So -8 divided by 2 is -4, squared is 16. So I'm going to add 16 to both sides. So I'm going to factor this. That's x minus 4 squared. And on the right side, I have 27 plus 16, which is 43. I'm going to square root it. That answer is positive and negative. And then the last step is I'm going to add 4 to the other side. So it's positive 4 plus or minus the square root of 43. So if I ask, what is the rational zero there? The rational zero is -3. If I ask, what are these zeros? 4 plus or minus root 43. Those are irrational. Complex would have an I, right? The square root of a negative number. And there's two of them here. So rational and irrational. That was pretty tough. This one isn't so tough. This would be something you could see on the exam. This is a diamond. Two numbers that multiply to -6 and add to -1. That's pretty reasonable. That's -3 and 2. And be careful of the exponent. It's going to be x squared, -3, and x squared plus 2. And then each factor equal to 0. And then I'm going to solve it. So I'm going to add 3. And then when I square root, it's plus or minus root 3. That is irrational. Too many r's. There it is. Now, what happens when I subtract 2 and square root? This is now imaginary because we have an I and the square root of 2 I can't simplify. But these you can call imaginary or complex. All right, let's keep going. Same thing, simple diamond, 63 and 16. That's 9 and 7. So 9 times 7 is 63. Add up to 16. So we have x squared plus 9, x squared plus 7. Make them both equal to 0 and solve them. So I'm going to subtract 9 and then square root. And again, when I square root, it's going to have an imaginary number. So I know I can square root 9, that's 3, but the square of -9 is 3i. Here, again, I'm going to subtract 7, and when I square root, again, the answer is going to be imaginary. It's plus or minus. In root 7, I can't simplify. So all of the zeros, every one is imaginary or complex. Both are fine. Here, this one feels like I can group it. So the first two, I'm going to factor out an x squared. The next, I'm going to factor out a -1. And then I have x squared minus 1, and I have x plus 5. So if I make it equal to 0 and I solve it, I get positive and -1. Here, if I solve it, I get -5. Every one of these, positive and -1 and -5, all of them are rational. So you have examples of rational, irrational, complex, having to complete the square. Pretty good stuff. All right, next page. What number are we at? 23. Here it is. Hey, use the factor theorem. So the factor theorem says, hey, divide, and if the remainder is 0, then the factor that comes from that, which is x minus 2, is a factor. So the first one does not give you a 0, so this one is not a factor because the remainder at the end is not 0. Let's try the next one, negative 4. Six, 30, 30. Any missing powers? All right, let's try it. Oh, look at this. It gives you a 0. So what factor comes from that is a plus 4, and that is a factor. Factor, yes. All right, what's the power term here? What's the most powerful term? Negative x squared. And what's the end behavior then? Well, that means both ends go down, negative with an even exponent. And then you'd write as x goes to infinity, f at x goes to negative infinity, that goes down. As x goes to negative infinity, f at x goes to negative infinity. So both ends go down. Number 26, again, it's negative x to the 5th. So we have a negative power term, so the right end goes down. Odd exponent means they go in opposite directions. So as x goes to infinity, the function goes to negative infinity. As x goes to negative infinity, the function goes to positive. So that means the right end goes down and the left end goes up. How about some graphing? So sketch each graph. So I love when it's already factored. Beautiful. So we have a 0 at positive 1 and it bounces. We have a 0 at negative 2 and it crosses. If I ask you about the end behavior, I need the power term. That's x squared times x. So the power term, if I multiply it out, is x cubed. That means the right end goes up and the left end goes down. If I plug in 0 for the y-intercept, I get negative 1 squared, 0, I get 2. So that's positive 1 times 2. So find 2. And so there's only one I haven't found that I'd like to find. And I can't use the remainder theorem because it's in factored form, but I need to plug in negative 1. So if I plug in negative 1 and negative 1 is negative 2. Negative 1 plus 2 is 1. So altogether that gives me positive 4. So use positive 4 and then don't be blurry. There it is. And then you've connected your graph. Again, I love it when it's factored. So we have negative 1. I got positive 2. And I got negative 3. And the power term, x times x times x, if you multiply it out, x cubed. So the right end goes up and the left end goes down. The y-intercept, if you plug in 0, is 1 times negative 2 times 3. So that's negative 6. If I use 1, what would 1 give me? So 1 plus 1 is 2. 1 take away 2. 1 plus 3, that's negative 8. So that's down here. And if I put in negative 1, is that right? Negative 2. I get negative 1, negative 4, and negative 1. So that's negative 4 altogether, right? Or positive 4. What did I do wrong? So negative 2 plus 1, negative 1. Oh, negative 2 plus 3 is positive 1. So this is positive 4. It had to be above. Okay, so negative 2 and 4. And then connect the dots, and you have your graph. What am I going to do here? So for this one, it's not factorable. So if I think of my list, I'm going to have to divide into my list and find a 0 the old-fashioned way with a list and dividing. It doesn't add up to 1. So positive 1 doesn't work because it doesn't add up to 0. So I'm going to try negative 1 and see if negative 1 works. I'm feeling okay about it, and it does. And then I'm left with this, and I know I can factor that. That's negative 3 and positive 1. So if I put it all together in factored form, I have x minus 3, x plus 1, and then negative 1 is x plus 1 as a factor too, so there's 2 of them, so it's squared. So now we're ready to graph. So we have negative 1 as an x-intercept. We have positive 3 as an x-intercept. I know the end behavior, x cubed, the right end goes up and the left end goes down. I know the y-intercept is the number at the end by itself, -3. And now I just need to plug in 1. Now I am going to use the remainder theorem here because it's not in factored form. So 1, -1, -5, -3. So 1 gives me -8. And I'm going to do the same thing. I think I'm going to just scoot over here. 2. Same thing with 2. With 1, -1, -5, and -3. Again, you should always press pause, right? And try it first. I get -9, which is a little bit lower. That's fine. And then I'm going to connect these together, and then I have my graph. All right, this one's a lot easier because you can factor out an x squared, x minus 2. So now we're easily graphing this. So it's +2 and 0. The power term again is up to the right and down to the left. Just +1 I need to plug in. Why not? We can practice this. 1, -2. We're missing 2 zeros at the end because for x and the number at the end. All right, I get -1 if I plug in 1, which is right. So 1 and -1. So it bounces at 0. And then you have your sketch. Good stuff. You can try it again on your own, right? And see if you can do it too the second time. Where are we at? 31. We're going to see if I might have to do a third video. That's okay. How do you simplify this? By factoring. So a factor out of 7x, I get 7x plus 5. Factor out of 7x, I get 3x plus 8. These cross out, and there's your answer. Factor, what's the big 4p? That's 7p minus 8. What's that? 4p, that's 2p minus 5. And then there's your answer. Dividing means you need to do the reciprocal. So as I do that, the denominator, I'm going to factor out 3a squared. And see if anything, so I see 3a squared crosses out, so I'm left with a minus 7 over a minus 9. When you multiply, you just need a factor. Now this one is a diamond, and so it's 27 and 1. So we have k plus 27 and k plus 1. Then we're going to divide by -3. So this gives me k minus 9, and this gives me -3k plus 1. The second one, so k minus 9 and -3k plus 1. And then the second one here, I need to factor the same thing. That's 9, -10. So it's -9 and -1. And again, I need to divide. So I'm going to divide by 3. So I have k minus 3 and 3k minus 1. And then what? These cross out, they're opposite factors, so leave you with -1. And that's it. So I have, I'll put it up here, I have k minus 9 left, and then I have k plus 1, k minus 3, and that -1. So we'll put that in front, and it's done. Hey, how about solving equations here? To solve a rational equation, the denominators need to be the same. So I'm going to multiply this by p, top and bottom. Now the denominators are the same. P can't equal 0 because it'd be undefined. Just write down the numerators and then solve it. So I'm going to subtract 1, and then I'm going to divide by 3. And so that's a good answer because it's not 0. Again, I need the denominators to be the same, so I'm going to multiply by a, top and bottom. When I multiply by a, all the denominators match. So I have a is equal to 3a minus a plus 1. Put parentheses around it. 3a take away a is 2a. That's -1. I'm going to add 1 and subtract a, and then I get my answer. Oh, and the two answers that A cannot be are 0 and 6. Those are the two ones A can't be. Here, we're going to multiply by V squared, top and bottom. So when you do that, you get 2V squared minus, 3V, squared. So I need a 3 in there. So that makes it 6V squared minus 2 equals 4. Add 2 and divide. The only number V can't be is 0. That would make it undefined. Here, I'm going to multiply. I guess I should factor it. So R minus 3. This is going to be R squared minus 3R top and bottom. So what this one needs here, so it can match. Sorry, I factored out a 2. So what do we need? So we need an R, and then it would match, right? I got R minus 3. So there's an R minus 3. There's an R minus 3. So it needs an R. So this one needs a 2. And this needs a 2. So let's see what we got. So I got R, 2R squared minus 6R, 2R plus 4. Let's see if that turns into something okay. So I got 2R squared minus 5R, subtract, and then subtract. All right, so it's going to factor. So it's negative 8 and negative 7, so that's negative 8 and 1. And then divide. We don't really need to divide by 2. So negative 8 and 1. And then divide by 2. So one answer is going to be positive 4. And the other answer is negative 1/2. And again, the two answers R can't be is 3 and 0. And so those are two good answers. That's a tough question, right? All good? Now what number are we at? 39. We're getting there. Can you graph some reciprocals? A is equal to 3, H is 2, K is negative 2. How does this break down? So we have 2 points, 1, 1, negative 1, negative 1. And we're going to change those. So we're going to add 2. And we're going to multiply. So 1 times 3, take away 2. Negative 1 times 3, take away 2. Put those points on our graph. Then the asymptotes, that's H and K. Those are asymptotes. So that's at 2 and negative 2. And then we draw the curves through those points. The domain x cannot equal 2, and the range y cannot equal negative 2. The end behavior, so the right end and the left end are both going to k, f of x, which is negative 2. All right, same thing, number 40, AHK. A is negative 4, H is negative 1, K is 2. So we have 1, 1, and negative 1, negative 1. Change those. So we're going to subtract 1. Then I'm going to multiply and add 2. Again, I'm going to multiply. That's positive 4 plus 2. So 0, negative 2, and negative 2 and 6. The asymptotes are x equals negative 1 and y equals 2, HK. So we have, what did I do? Negative 2 and 6. There it is. This is the asymptote. And then 2 is an asymptote. And then you would draw it from there. So there's your curves. We know the domain x can equal negative 1, the range y can equal 2, and then the end behavior. If you want to, you can write down positive and negative infinity because both ends go to the same place. You can just write it together and not have to write it twice, or you can write it separately. Number 41. First thing we're going to do is factor this, so that factor out of 3. And then we have an x-intercept at 3. If I plug in 0, the y-intercept, so the x-intercept is at 3. The y-intercept is negative 9 divided by negative 4, which is like 2.25. We have a vertical asymptote at 4, x equals 4. That's what makes the bottom 0. We have a horizontal asymptote at 3. Divide the power terms. And then I have a curve here. And the other curve is going to be up here. So 5, will that give me, 5 will give me a nice answer. So 5, 3 times 5 is 15, take away 9 is 6, 5 take away 4, so that's 6, 5 and 6. And then you can draw your curve from there, and there's the second curve. Is there something I didn't write down? Domain, x cannot equal 4. And both the ends, so I'm going to write it as one, positive and negative, both ends are going to the number, the horizontal asymptote, which is 4. Right? No, sorry, not 4, 3. The horizontal line. All right. This will be my last one, and I'm going to have to do one more video to finish it off. So I'm going to factor out an x, factor out a 3. Now recognize here, we're going to have a hole, because it crossed out at 3. And then what's left over is just x minus 3. So if I plug in 3, then the hole is at 3, 1. Oops, hole. This is just a line that's left over. So I'm just going to graph the line 1/3 x. The x-intercept's at 0. The y-intercept's also at 0. I can use that hole. It goes up 1/3. It's just a line with a hole in it. So there's a line with a hole in it. The domain, x can't equal 3. The range, y can't equal 1. The end behavior, the right end goes up, so we can't do it as quick as the other one. So the right end goes up and the left end goes down. All right, let me do one more. Let's just try and see if I can do this. One more. All right, I'm going to factor this. Factor out an x. So 0 is the x and y intercept. No hole. We have horizontal asymptote -3. Then the bottom is more powerful, so it's at 0. We have vertical asymptotes at 0 and -2. Oh, wait a second. What happens to the x's? There is a hole here. That's not a point. So we don't have any intercepts, because there's a hole there. So at 0, when I plug in what's left over, the hole as 0 is at -3/2, so -1.5. So we have a hole at 0 and -1.5. That's a hole. No intercepts. We have a vertical asymptote at -2. So this is what's going to curve here. And then the other curve is going to be up there. So if I plug in -3, that gives me 9. Well, here. -3 gives me -3 over -1. That's 3. So -3 gets me 3. I just use this. This is the function now I'm using. -3 over x plus 2. So if I plug in -3, I get -3 over -1, which is 3. So -3, 3. Draw your curve. And so again, you have a curve with a hole in it. That's it. Mr. G Math over and out. I got to 43. I'll do another one, post another one tomorrow. I'm really proud of you that you're working as hard as you can through this. I know it's not simple, but I do believe you can do this. You can do great on the exam. Till next time.